Okay, so I'm going to show some animations to kind of make the concept stronger in your head about normal conditions, El Nino conditions, and La Nina conditions. These animations are cute and they will help you, okay? So let's look at how normal conditions develop. So this is the figure we have seen before where you have shallower, where is my cursor, there it is, shallower thermocline in the east, upwelling, coastal upwelling, southeast northeast currents, dragging the cold water westward, getting heated along the way, creating the warm pool in the west, rising air, condensation, and the Walker cell upper branch going east and sinking, subsiding over the cold, high pressure waters in the east. So subsidence makes the high pressure, pressure gradient makes the winds, so you have this loop, right? How does it develop? Let's look at this in a simple way. So let's start with the flat, no winds, flat ocean. Pacific is sitting peacefully. Thermocline is flat. Warm water near the surface. Cold waters below the surface, below the thermocline. We put in a high pressure in the southeast Pacific, let's say around Tahiti, and we put a low pressure in the west, around the just west of the dateline to the east of New Guinea. So this pressure gradient is going to drive southeast winds. You have to add Coriolis because the pressure is off the equator, and that piling up of warm water is going to start rising motion. The rising motion is going to expand, condense, and the air is going to hit the tropopause, go east. We are only looking at the eastern parts. Obviously, it's going in Hadley cell as well as west. We are focused here on the Walker cell in the Pacific. So that air is sinking. So you have now established the Walker cell. You have established the cold tongue and the shallower thermocline and the warm pool, and the entire cycle is complete of going into normal conditions. Okay, you can watch the video again. I'm not going to play it again, but this is how the normal condition gets established. I'm going to do the El Nino conditions in the next podcast so that you can just look at this podcast of normal conditions as often as you want to make sure you understood it. Okay, it's only 2 minutes long, but it helps you to look at it again and again, where the low pressure is, where the high pressure is, how the pressure gradient is, and how the upwelling happens, how the trade winds get set up, where are the positive feedbacks, and normal conditions with the east-west temperature gradient and pressure gradient and winds is established. It's in equilibrium, right? So even though you have a gradient, the winds have matched the gradient, the rising motion and the sinking motion have matched the gradient, so you are in an equilibrium condition. So that lasts for many, many years before something pushes the system away from equilibrium. As I said, we don't always know whether El Nino is just an oscillation so that it keeps going back and forth like a pendulum, or if somebody kicks the normal condition to go into a El Nino. That's a very deep dynamic argument that goes on and on and on, which means we don't know exactly the answer. But nonetheless, we know that normal conditions exist, and then El Nino or La Nina come along. And when they come along, we know because many things begin to change. That's the crux of how we want to be able to forecast it. Okay, so remember normal conditions and the associated rain patterns where they are, dry patterns where they are, related other teleconnected regions like the monsoon over India, East